Hello everyone, in this video we are going to learn about context-free grammar, derivation tree and derivation tree with ambiguity. A context-free grammar CFG consisting of a finite set of grammar rules is a four tuples N, T, P, S where N is a set of non-terminal symbols, T is a set of terminals where N intersect T is always equals to null, P is a set of rule where N gives N union T star, that is, the left hand side of production rule P does have any right context or left context. S is the start symbol. The example of N are capital A, capital B, capital S, etc. The example of T is small a, etc. In formal language theory, context-free language is a language generated by some CFG. For example, for generating a language that generates equal number of A's and B's in the form of A to the power n, B to the power n, the CFG is given as, here capital S and capital A are non-terminals, small a, small b are terminals, P is the production and S is the start symbol. Here S gives AAB and A give AAB and epsilon. Say for example, we want the grammar A to the power 3, B to the power 3. Here are some steps. We use both this production and finally get the result. Now what is derivation or parse tree? A derivation tree or say parse tree is an ordered rooted tree that graphically represents the semantic information of a string derived from a context-free grammar. The representation technique of parse tree is, the first one is root vertex. It must be labeled by the start symbol. Vertex. It is labeled by a non-terminal symbol, for example capital A, capital B. Leaves. It must be labeled by terminal symbols, for example small a, small b or epsilon. For example, if S gives x1, x2, so on is a production rule in a CFG, then the derivation tree will be as follow. Here in this derivation tree, the root is S, the starting symbol, and the terminals are x1, x2, xn, and they are present at the leaf node. There are two different approaches to draw a derivation tree. The first one is top-down approach. It starts with the starting symbol S and it goes down to tree leaves using production. The second one is bottom-up approach. It starts from the tree leaves and it proceeds upward to the root, which is starting symbol S. There are two types of derivation of strings, leftmost and rightmost. The leftmost derivation is obtained by applying production to the leftmost variable in each step. The rightmost derivation is obtained by applying production to the rightmost variable in each step. Now we will see some example. The first one is leftmost derivation. Let any set of production rule in a CFG be. Here x gives x plus a or x into a or x or a, the string a plus a into a. The leftmost derivation for that string is, here we first use plus operator, then into operator and then a production. For the same, the stepwise derivation of the string is, here first we use plus operator, then we use into operator and then we use a production x gives a. The second is rightmost derivation. Here for the same string a plus a into a, first we use into operator, then we use plus operator and then a production. The stepwise derivation for the same string is, here we use into operator, then plus operator and then x give a. Now it is clear that for the same string we have two or more derivation trees, and hence this grammar is ambiguous in nature. Ambiguous grammar. If a context-free grammar G has more than one derivation tree for some string W that belongs to L of G, it is called an ambiguous grammar. It means there exists multiple rightmost or leftmost derivation for some string generated from that grammar. If every string in L of G has at most one parsed tree, then G is said to be unambiguous grammar. We can remove ambiguity of grammar. Sometimes we can remove it by hand, but there is no such algorithm to do it. Some context-free languages have only ambiguous context-free grammars. Say for example, E give I, E plus E, E into E and E. But there are two problems. The first one is we don't know the precedence between into and plus, and the second one is there is no grouping of sequences of operators. That is, we can solve it by brackets, but here no brackets are given, so we are unknown to the fact. We can remove ambiguity by using or by changing the name of variables, by adding some new variables and making the tree more complex, but it is the method to remove ambiguity. Thank you.